This is a part of the series in solving elements of symmetrical curves. Welcome to Engineering Surveys. The problem describes the curve having a back tangent with grade of positive 4% and forward tangent of negative 2%. The allowable rate of change per meter station is 0.3%, and the details of PVT are elevation of 156.58 meters and station 12 plus O80. We are to determine the length of the curve. By length, we mean the horizontal distance. We also need to find the location of the highest point from PVC and its elevation. Let's visualize the curve by illustration, with the back tangent rising to the right, followed by the decline of the forward tangent. We can also place points PVC and PVT, with the details of its elevation at 156.58 and station of 12 plus O80. Also note that the allowable rate of change of the grades is 0.3% per meter station. Let's start with the length L. In order to solve this, we need to know the horizontal distances of each tangent, given their grades. The other parameter to help in the solution is the rate of change of gradients allowed to 0.30%. Given that the rate of change is 0.30 per meter station, we need to know how many stations are covered by both tangents. Assuming n as the number of stations, we can solve this by taking the change of the grades over the allowable rate of change. The change of grade is G2 less G1, as they are on the opposite directions. Then divide these by the rate R. N is negative 2 minus 4 upon 0.3, which shows negative 20. Take note that there is no negative number of stations, and the negative in the grade only shows that it runs downward. N is then 20 stations. With N already figured out, we can solve for the length. The premises stated the change per 1 meter station, which means the distance between stations is 1 meter. So L is 1 meter times 20 stations, giving 20 meters. Next is to find the distance of the point of highest elevation from the point of curvature. This is easily solved using the grade diagram, as it is similar with looking for the maximum moment in beams when discussing strength of materials. So draw the grade diagram with positive 4% going up and connected down with negative 2% on PVT. The whole length is then broken down into the summation of S1 and S2. Then, taking similar triangles, we take the small triangle which includes S1. That is, S1 is to G1. And then equate this with the bigger triangle. Why do we equate it with the whole length? It is because we are avoiding to place S2 into the computation. The ratio from the bigger triangle is L is to the added gradients G1 plus G2. Cross multiply G1, then plug in the values from the example. We get 0.04 times 20 over the summation of 0.04 and 0.02. S1 is then computed as 13.3333 meters. This is the distance of the highest point from PVC, which means the point is after PVI or at the right side of the curve. The next task is to look for the elevation of the highest point of the curve. The elevation will now be based on PVT, as it is the one with a given elevation of 156.58 meters. There are two ways of solving for the distance of the highest or lowest point from PVC or PVT. The first one is to use the area of the grade diagram, which is simply half of the base times height. Since we are taking the height from PVT, we are to use the second triangle with S2. So let's solve S2 first from the total length minus S1. That is 20 minus 13.3333, which turns out as 6.6667. Use this value as the base in the area of a triangle. That is half of 6.6667 times the height of 0.02. Disregard the sign of the gradient as we are looking for an area anyway. H2 comes out as 0.0667. Another method in taking the distance of the point to either PVC or PVT is using the offsets of points on the curve. That is using the square distance of parabola function, as we are to look for y. The proportion we would use this time is the square of x is to y as the square of half of L is to h. With so many parameters involved, let's check which we already have. Y is the one we needed, and x is S2, which we already figured out. L is also solved as 20, but we still don't have h. From the list of functions, we have h is equal to an 8 of L with g1 minus g2. Plug values to have 1/8 of 20 with 0.04 minus negative 0.02. H turns out as 3/20. Knowing h, we can now compute for y using the proportion, which becomes the square of 6.6667 upon y as equal to the square of 10 all over 3/20. Y turns out to be 0.0667. This is the same as what we saw from the area of the grade diagram. Having known the height of the point from PVT, we can then take the elevation starting with the given of 156.58 as elevation of PVT. Add y of 0.0667, which gives the elevation of the highest point, which is 156.6467 meters.